All right, today we're going to talk about a little bit more of absolute value, specifically when there's a number in front of my absolute value symbol. That number is often referred to as just A. And when that number is in front of that absolute value, my absolute value graph, my V shape, is going to either be stretched and become narrower or compressed and become flatter. It's going to look a little bit like these two graphs below that I want you to go ahead and sketch. So when I have 2 in front of that absolute value symbol, this graph actually becomes narrower. And it looks like this. I have in pencil here the our original absolute value graph. And then this one in blue was what happens when I have a 2 in front of it. Over here again, I have my original absolute value graph in pencil, but when I have 1/2 in front of that absolute value symbol, this actually makes my graph wider. So those are my two different situations. When I have a number greater than 1, like 2, for example, it essentially stretches my graph and it becomes narrower and starts getting skinnier as it goes to the top. But when I have a number less than 1, like a fraction, it's actually shrinking my graph down. It's compressing it. It becomes wider. And so those are the two different transformations we have happening today. We're going to do these algebraically, and then I'm going to show you how to do these using slope. So algebraically, we kind of need to remember that anything that goes into the absolute value symbol comes out positive. When I plug a 6 into that spot, so 1/3 times the absolute value of 6 plus 2, I'm essentially taking 6 divided by 3. 6 is already positive. So 6 divided by 3 is 2. And when I add 2 to it, I get 4. And so my first point on my graph is 6, 4. Then I have, let me actually zoom in here. Then I have the number 3. I'll plug in the same way. I'm going to do 1/3 times the absolute value of 3 plus 2. Again, when I'm doing 1/3 times 3, it's just dividing by 3. So I have 1 plus 2, which is 3. And so the next point I'm going to plot is at 3, 3. Next one is 0. 1/3 times 0 is just 0. And so when I add 2 to it, I get 2. So 0, 2. Next one, I have -3. So this one, we're going to use that absolute value symbol. When I do 1/3 times -3, well, that -3 is actually a +3. It's really 1/3 times +3, because anything that goes into the absolute value symbol comes out a positive. So 1/3 times 3 is 1. And when I add 2 to it, I get +3. So I'm going to count over here to -3 and go up to +3. And then the last one is -6. We're probably running out of room. So 1/3 times the absolute value of -6 is going to be +6. And 6 divided by 3 is 2. And when I add 2 to it, I get 4. And so we have this nice pattern over here at -6. We're up to +4. And this is my V shape. It is much flatter than my original parent function. This is one of my compressed absolute value functions. Let's do number 2 together. I'm now going to plug in 5 into the x spot there. So 5 minus 1, and I will multiply that times -2. So 5 minus 1 is 4. And when I multiply that times -2 on the outside, I get -8. I'll do the same thing here with 3. -2 times 3 minus 1. In other words, -2 times 2, which is -4. And the same thing with 1. I'm going to have negative 2 times 1 minus 1. So in other words, negative 2 times 0 is 0. My next one, negative 2 times negative 1 minus 1. In there, I should get negative 2 times the absolute value of negative 2. But the absolute value of negative 2 is actually positive 2. So negative 2 times positive 2 gives me a negative 4. So it's not a positive 4, it's a negative 4. And then my last one, negative 2 times absolute value of negative 3 minus 1. Negative 3 minus 1 is negative 4. But again, it's the absolute value of negative 4. So I really have negative 2 times positive 4, which is negative 8. I definitely did not give you enough room. If you need a piece of scratch paper, please grab one. And let's plot all these points. So if I have 5, negative 8, I'm going to count over 5 and down to negative 8 and plot my points. 3, negative 4, I'm going to count over 3 and down 4 and plot the points. 1, 0 is right here. Negative 1, negative 4. And negative 3, negative 8. This last one I will get started for you, but I want you to end up finishing it on your own. 3 times the absolute value of 4 minus 4. So 3 times the absolute value of 4 is 12. Minus 4 would give me 8. You should be able to fill in the rest and do this graph. When you're ready, flip over to the next page. Let's do some reminders about slope because we are going to graph using our vertex and our slope. This is much easier. It is definitely the shortcut. And so we will probably do it this way for the rest of the assignment. Reminders about slope. Slope is my rise over my run. So I'm going to move in the X direction followed by, move in the Y direction followed by my X direction. All right. In general, positive slope tends to look like this. We go up and to the right. In general, my negative slope tends to look like this. I'm going down and to the left. Now, absolute value, the right and left is really not going to matter much, but we will use it for the first part of this. On number 3, let's first identify my vertex. Again, we change this sign, keep this sign. So if I have x plus 1, my vertex is negative 1, and minus 2, I'm going to keep that negative 2. All right. Now I'm going to plot that vertex, negative 1. I started my origin, negative 1, negative 2. There's my vertex. But now I'm going to move according to my slope. Your slope is going to be whatever number is in front of that absolute value symbol. So here, my slope is 2. Anytime it's not a fraction, I'm going to rewrite it as 2 over 1. So I'm going up 2 and to the right 1. I'm going to go from this point, count up 2 and to the right 1. And I'm going to make a new point and repeat that process. Up 2 and to the right 1 until I run out of space. With absolute value, I am not going to continue this pattern down here. This slope needs to now happen going up 2 and to the left 1. I'm going to do the same slope just in the opposite direction. I'm essentially going to create a negative slope here. Positive number, my absolute value should be going up in the positive direction. If I have a negative slope like I do here, I know that my absolute value is flipped upside down. So let's practice that one. Again, I have to start at my vertex. Change this sign so it becomes a +6. I don't have anything over here, so it's a 0. So I'm going to plot my vertex at 6, 0. And then I'm going to move according to my slope. My slope here is just a negative sign. It's really just -1. So I'm going down 1 over 1. Down 1 to the right 1, down 1 to the right 1. I've run out of room over here. I need to move also downwards in this direction because it needs to make that upside down V shape. So down and to the left, down and to the left, all the way until I run out of graph paper. Last example I'll show, we're going to do our vertex, and we're going to move according to our slope. Our vertex, change this sign, -1. Keep this sign, -1. Plot that point, -1, -1. And then my slope is 2/3. So I'm going up and to the right to start off with. Up 2 to the right 3. Up 2 to the right 3. I'm going to do the same direction, but I'm going to go up and to the left now. Up 2 and to the left 3. You are going to repeat the same pattern for number 6, as well as the 6 questions on the next page.